Welcome to Summarize Science. Today, we are looking at a breakthrough in robotics called Gaze2Act. Robots are getting much better at following instructions, but language is often too vague for complex, real-world tasks. Think about asking a robot to pick up the cup when there are 3 identical cups on the table. This paper explains how researchers are using the human gaze to make robot control much more precise. The researchers found that where we look is a powerful, real-time signal of what we actually want to do. By tracking a person's eyes, the robot can understand exactly which object a user intends to interact with. As you can see here, language instructions can be ambiguous, but gaze attention is incredibly accurate. This allows for tasks like precise pick-and-place, part-level manipulation, and even steering a robot mid-motion. Traditional models rely mainly on words, which lack the spatial precision needed for fine-grained work. They propose that gaze is not just observational, it is a direct manifestation of a person's motor intention. The Gaze2Act framework aims to seamlessly integrate this human gaze into vision-language action policies. To make this work, they use smart glasses to capture where a person is looking from their own perspective. The system then maps that first-person view into the robot's perspective using a clever semantic matching process. Once the target is identified, the robot creates visual prompts like object contours or heat maps. These cues tell the robot's brain exactly which regions to attend to during a task. This mapping process is training-free and doesn't require complex camera calibrations. The system creates a continuous spatial heat map to provide a soft and robust guidance signal for the robot's sensors. This is much more reliable for visual policy learning than just using a single, static coordinate point. They evaluated Gaze2Act using a Unitree G1 humanoid robot across 16 different real-world tasks. The experiments were designed to see if the robot could resolve ambiguity and update its target during execution. To ensure a fair test, they compared Gaze2Act against several other state-of-the-art robotic baselines. The results shown in this table are quite impressive. Gaze2Act achieved much higher success rates than traditional methods, especially with ambiguous or unseen objects. It reached 93% intent accuracy across object-level tasks, far outperforming standard language-only models. The system even excelled at compositional tasks that require the robot to manage 2 different references at once. Here we can see the robot in action, following both coarse and fine-grained gaze cues. Whether it is picking up a specific fruit or grabbing the handle of a hammer, the gaze provides a clear target. The robot can even handle transparent objects, which are notoriously difficult for standard vision sensors to detect. One of the coolest features is dynamic intent steering. If you change your mind while the robot is moving and look at a different cup, the robot redirects itself instantly. This creates a much more natural and fluid way for humans and robots to work together in the same space. To summarize, the researchers have created a way for robots to see our intentions through our eyes. This overcomes the fundamental limits of trying to describe every single detail with just words. In the future, this technology could make home assistant robots much more intuitive for everyone to use. It marks a shift toward robots that don't just follow scripts, but truly collaborate with us in real time. Thanks for watching Summarize Science, and stay tuned for more breakthroughs.